for the second distribution. So with that, we are going now to try the probability. Okay, remember, like this example, we've said that we want to calculate that. Okay, like for example, suppose we know that 20% of all the credit cards transactions in a certain region are fraudulent. Okay, so if there are 50 transactions per day in a certain region, we can use binomial distribution to find the probability that more than a certain number of fraudulent distributions occur in what, in a given day. Okay, so with that, we are going to that is calculate, like for example, the probability that we will have that is fraudulent, that is activities in transaction, or in 5 transaction, or in more than 5 transaction, meaning it's either 6, 7 up to 20. Okay, so with that, we are going now to use the two methods, the manual method, okay, and the what, and then we'll also go with the Excel inbuilt function method. Okay, so with that, we have n combine what, n combine x, and with this, we can either maybe now do it manually using the formula which I told you. And the formula, I said, it is n factorial divided by x factorial into n minus x factorial. Okay, you can do that manually, but for this, allow me to use that is the combination, that is combination formula. Okay, the combination formula in what, in Excel. And so we are going to use that is compin, which will return the combination of the that is of the given number of items. So we are going to use this. Then we need what, the total number of that is of the items. Okay, and with that, we have 30 trials, so we will use 30 trials. And I'm going to lock that is that cell 30 trials, because I've just put it in a single cell. Okay, so we can always what, we can always reference that cell. Okay, then comma, the number chosen. Now we want to combine with what, with x, and combine x, and then you can do what, you can drag. So you can see now, this is the, that is our outcome in terms of combination. Okay, then let's come to the probability. What is the probability of maybe getting a fraudulent and what, or so in this case, we have two possible outcomes. Okay, we have two major possible outcomes, like for example, or we can go with this. Okay, you can see that suppose it is known that 2%, okay, of all credit transaction in a certain region are fraudulent. Okay, so we are going to assume that we have a probability of what, 0.02. Okay, that is a probability of success will be just a minute, I internalize it. So suppose it is known that 2% of all credit transaction in a region are what, fraudulent. Okay, so here we are checking now if they are what, they are fraudulent. Okay, so now we are going to use the probability of maybe success, and probability of what, of failure. Okay, meaning we only have very small that is probability when it comes to what, fraudulent activities. So in that case, we are going to use what, 0.02, 0.02 just a minute. This is probability of success. So if it is success, it means we have what? Yeah, so it will be 0.2, meaning that is, if we have this probability of 2%, then it means most of our transactions are good. Okay, if maybe we have a probability maybe of 0.08, okay, then it will mean what? That is, most of the what? Most of the transactions will be what? Will be fraudulent. So we'll use that probability all across. Then we have the probability of failure. So it will be 1 minus what? 1 minus p. Remember that it's what we discussed in our class. Okay, so this is the probability of what? Of failure. Okay, then we have n minus what? N minus x. N is 30. Okay, so with this case it will be equal to, we can say it is 30. Okay, minus, you can say it is 30 minus now the x here. Okay, it will be 30 minus the x, so then drag it down, okay, to that point. Then we also need what? We also need p raised to x. So for p raised to x, it will be equal to p raised to x. So it is this probability raised to what? Raised to the to x, which is this one. Okay, and with that you can also drag it down. Okay, then after that we need what? Q raised to n minus what? Q raised to n minus x. So it will be equal to q, which is this one, raised, q, it is raised to n minus what? It is raised to n minus x, and then calculate that. So with that we have all the values we need to calculate now the final probability. Okay, so with this will be equal to this n combined x multiplied by p raised to x, which is that one, multiplied by q raised to n minus x. Then here are our probabilities. Then we can do what? We can drag it down. Okay, and after that now we will come now to the interpretation part of it. Okay, right. So we have now here the probability of maybe one fraudulent activity happening. Okay, it is what? It is very high. You can see the probability of getting one that is fraudulent transaction. It is what? It's very high. Okay, then probability of getting two, it reduces. You can see it has reduced, in fact by a big margin. Okay, you can see it has reduced to what? To 0.09. Maybe I can do a conditional formatting so that we may be able to notice that decrease. Okay, so you can see the I that is red for the highest probability. Okay, so meaning the probability of getting what? That is of getting 8 fraudulent activities in transaction, in maybe 8 transaction, it is very, very low. Okay, yes, so with that you can see we have that is the probability. They are true, they are looking good, because the probability of getting one fraudulent activity that is within what in 30 transactions or 30 pack of transaction, it will be what? It will be high. And the more the fraudulent activities maybe you assume, the less what? The less the probability. Then as well we can also present this in what? In a graphical that is distribution. Okay, or in a graphical representation. So with that, you are going to highlight the two columns, the probabilities columns. Of course, it will be our y column, and then x as our, that is the total number of what, of trials. Okay, so we are going to that is use, you can either use that is line graph, or you can as well use what, um, column, but column it's not giving us something good. You can as well use column. Okay, here it is column, right? And you can now see that is the probability of what, of getting that is a one front end event or transaction is what, it's I. Okay, and with this it might change with what, with also the probability. Like for example, if we say the probability of getting that is fraudulent transactions in a region, it's very high, meaning that area it's prone to what, to fraud. Okay, so let's assume now the 0.998, it's what, it is the maybe the probability of getting a fraudulent event. Okay, so you can see now the probability distribution now will change, meaning the probability of getting all the transaction, okay, to be that is to be what, all the transactions to be fraudulent, it is what, it is very high. Why? Because that area maybe it's prone to what, to high fraud. Okay, what about when we say 50-50? Maybe we use 50-50 that is probability. So if it's a 50-50 probability, you can see we have like almost even what, even evenly distributed that is transactions. Like for example, you can see if the case is 50-50, meaning we can have a fraud or a clean or legit transaction. So it will be also 50-50, and the probabilities will also shift to the, to almost the 50 area. Okay, that is from 10 to maybe 17. Okay, so meaning the probability of getting 13 legit and also 13 fraud transactions, it is what, it is high. Okay, yes, now that's the manual way. We also have now the that is the Excel function way. So we are going to find the function of x. So with that, we usually use binomial binomial distribution, and you can see for for binomial dist, we have it returns the individual term binomial distribution. Okay, yes. So with that, we are going now to go with the number of what, number of all trials, or sum of all trials, and we said it is what, it is 30. And with that, we are going to do what, to lock that specific what, that specific cell. Okay, then after that, we'll go now to the individual trials, that is successful trials. Okay, and then after that, now we'll go to the what, to the probabilities. Okay, and for this probability s, we are talking about that is the positive probability. Okay, so it will be p, the positive probability, comma, and then we need what, we need probability mass function. So let's do that and see, maybe that is, sorry, it is giving me an error. So let me redo. We have binomial distribution. So with that, we need the total number of what? Okay, sorry. I should have started with what? I should have started with these trios. Sorry for that. Comma, then go to total. You can see we have trios. All the what? All the trios. So all the trios, I'm going to use this one, and then I'm going to lock the cell. Okay, because I'm using that as a reference point. Hello, guys. Are we together?
Yes.
Okay, good. So I'm going to use that is the total trials, then comma. Now we need what? The probabilities. That is now this the sample probabilities. So we have the sample trials or the success. Let me just say, you see the S here. We have the number of success trials, comma, all the number of trials, then comma, the probability of what? Success. S for success. And then close that. Something not I've entered few. Oh, I've entered few arguments. Then comma. We need what? Comma, then I need probability mass function, and then run. Okay, if I run, I'm going to get what? You can see I'm getting the same values. You can see I'm getting the same values, meaning my what? My that is my method is what? It's very correct. Okay, that is that is a manual way. It is very correct. So with that, definitely the formula always guides on that. Okay, so that's the probability, that is mass function. Maybe you were wondering, why are we not using cumulative, that is cumulative probabilities. But what cumulative probability basically does, it does like this. Like for example, it takes this probability, okay, then the second one will say, now I want this plus what? Plus this, okay. Yes, and that you can see now here, it is taking that plus that, okay. So at the end, you'll find that as we had these probabilities, they are approaching 1. You can see they are approaching 1. Okay, you can see they are increasing. Okay, they are approaching to 1. Okay, so basically that's the cumulative, that is function. So like for example, if I am saying that this is binomial distribution, okay, binomial distribution, then I want the number of success. Okay, where is the number of success? Here it is. Then we need the total trials. The total trials are 30. So let me, that is, lock that cell. Then we need what? The positive probabilities, and then after that we need what? Cumulative probabilities. Let's go with cumulative probabilities. And you can see with the cumulative probabilities, we are getting what? We are getting the same value. Okay? You are now getting the same value. All right. Then what about, this is for binomial distribution? Okay. What about when now we are talking about binary? Remember for binary, I said when now, that is, that is your n is 1. Okay. When when n is 1, okay, then you'll get what? You'll get, that is a binary, that is, you'll get a binary distribution. Okay, and with that case you'll also get what? You'll get, maybe one value. Why? Because if n is 1, then you can't have two what? You can't have two trials. Okay, if n is 1, you can't have what? You can't have two trials. Any question under binomial distribution? Any question under binomial distribution? Okay, good. So we are done with the Poisson distribution, okay, and then binomial distribution, okay. So maybe the remaining part or the remaining distribution, it's the normal distribution. So tomorrow we can meet and now discuss that is a normal distribution because it takes sometimes. Okay, you can see because we have very many that is variables here. But on my case, I will leave you to do the manual part as an exercise. So tomorrow, what I will do, I'll do what I'll do. That is the inbuilt function. Only this inbuilt function. Then for you, I will leave it to you to now calculate what this manual example. Okay. Yes. So